working out the area and perimeter of a larger triangle using similar sides. So suppose we have two triangles, one inside the other. We've got a little triangle in here, 3.2 along the bottom and 2.3 on the other side, and then a larger triangle, 6.8 on the bottom. And notice that these sides are all similar. If we say we multiply this one by approximately 2, we get these. Remember, it's not to scale completely, but may not be drawn up perfectly, but longer side approximately twice the shorter side there, and this side here is also similar to this side here, so you approximately multiply this one by 2 as well. Whatever we've done to get the longer side from a shorter side, we have to do the same thing to another shorter side in order to get the other longer side. Okay, so I just want to go to a website just for a moment. Got this website here, Similar Triangles, and if you go to mathopenreference.com or mathopenref.com, you'll be able to see a little bit about similar triangles here. Now notice that they've done this long side here. This triangle is about double this short side here, but they are similar sides. In the same way, we've got 11.3 and we've doubled that. It's a similar side over here, 22.7, and likewise got 6.9, we double that to get 13.8 over here. Both of those ones are similar sides. Okay, just remember though that you don't necessarily double. It could be tripling everything. You could triple this side to get that one. If you tripled that side to get that one there, if it was a bigger triangle, then it would make the triangle bigger, and you'd have to triple this side in order to get the similar side over here as well. It could be 1.5 times as big, it could be 10 times as big. You have a really super big triangle, and then you'd have to multiply every single side by 10 to get all of the similar sides of a triangle there. Alright, so whatever you do to one side to get the other side that is similar, you also have to do to any other little side to get the other big side. Alright, it's similar. So just to explain that there, and you can just experiment with some of these things here, move them around. You can see that everything is always double. It doesn't matter what you do here. You know, if the angle's all the same, and everything's always double. Alright, so alright, in this particular case. So just to get rid of that, now let's get on with the question. So we've got two similar triangles and several similar sides. The only difference to this website is we've got taken the actual triangle itself and put it inside the little triangles inside, right inside the big triangle. Now to solve this, we're going to have to work out this entire side here and this side here, because you'd need it to be able to work out the perimeter, and you actually need them to work out the area as well. Now we can actually work out V, and it's a little bit difficult to see how to work out U to begin with, but V can be worked out using our similar triangles formula. Let's have a look at our similar triangles formula here. We've got let's bring it up. The long side, the first long side, all this means with subscript, by the way, is just long one, the first long side, and we can call that our V value, over our short first side, which is the corresponding, or the similar side here. So that side's parallel and it's very similar. Whatever you do to that one, this one here could be doubled to get that one there, as long as you're doubling everything else as well to double that to get that, if you're doing that. Okay, so what we're saying is a relationship here between the long and the short is exactly the same. It's equal to the relationship between the long and the short, the second two sides. So the relationship between this 3.2, whatever it is, like almost half or whatever, and the 6.8. Remember, it's not drawn completely to scale. All right. The relationship there of being roughly a half is going to be the same as the relationship between this v and 2.3. Alright, so write up the formula as long over short equals long over short, and start with your unknown letter, because it makes the algebra a lot easier. So if you start with your unknown letter here, we've got v over, which is long side, over its matching or its similar short side, which is 2.3, and then equals the 6.8 over its matching short side of 3.2. Alright, then we can move the 2.3 onto the other side. It becomes times 2.3 and it disappears from that side there. So you just got v equals 6.8 divided by 3.2 times 2.3 equals 4.8875. So again, we've taken a few extra decimal places to ensure our accuracy in our final answer. We haven't got to our final answer yet, but we need to work out, using Pythagoras, work out u. Now we couldn't work out u using the similar triangles method that we used over here. We can't do that, not in this case here, because in order to do that you would actually have to have at least one other side or similar side to u. Remember, we've got v here and we've got a similar side of 2.3. Well, that's why we could use the formula, but u does not have a similar side given. No, so you can't use it. You're going to have to work out u using a different method. Now we know what v is already, and we know the other side of the triangle, so we can therefore work out a third side of a larger triangle. And using Pythagoras here, we've got the longer side squared minus the other short side squared, and minus to get a medium side, and or medium or short. Anyway, the point is that it's shorter than the long side, and you take the square root of it, and you end up with 4.7278. Now, once again, I haven't rounded it completely because I want to use this result in my final answer when I do the perimeter and area. All right, now perimeter is all the way around, and that's a u plus a v plus a 6.8. You're adding everything else, everything that we've worked out so far, including the 6.8 along the bottom there. Okay, so you add them together. It doesn't matter what order you add them in, but you should end up with 16.42, and now you can round it off to 2 decimal places. However, the rounding probably didn't matter too much in that particular case. Even if you used 4.89 or whatever it is, cut it off into 2 decimal places. Well, actually, it might actually, hang on, yeah. No, this might actually illustrate the point that we do need to take extra decimal places. In many cases, we do need to take it, and I wouldn't take the risk. Okay, so that cutting it off earlier on could well have affected our result. We might end up with a slightly different result if we cut off the decimal places too early. Alright, so same thing for our area as well. So we've got the two sides that are closest to the right angle multiplied together, divided by 2 to give us our area of a triangle. Make sure you divide by 2. Remember, a triangle is half of a rectangle. In a rectangle, you would multiply those two together, the two sides there, not the diagonal. You'd never multiply your diagonal to get the area of a rectangle, would you? So you just look at the two sides that you would do. You would work out the area of that rectangle, and that triangle is half of a rectangle. You've got to divide by 2. Make sure you divide by 2 at the end. All right. Okay, now let's look at the next bit here. If we are instead trying to work out the area and perimeter of a smaller triangle using similar sides. So before we worked out the area of a larger triangle, now we're working out the area and perimeter of a smaller triangle. Right, now I've labelled the sides. I don't actually need my V here, mind you, but sometimes there are extra labels in there. Maybe just throw it in there just to let people know that sometimes it's confusing extra information that you don't need that is given to you in tests and that. But all we need really in order to work out the perimeter is our U and our T, because then we would be able to work out everything all the way around, and it looks like we don't even need V as our intermediate step either. But if you also try to work out the area, you've also got U times the T divided by 2, because that's a right angle there, remember. Okay, so that's a similar, angles are the same for similar triangles. That one there goes there. Okay, will be a right angle because those ones are parallel. Actually, corresponding angles in fact are the same. That one's a right angle, that one will be a right angle, just corresponding angles on parallel lines. Alright, so it's a right angle triangle. Even the smaller triangle is a right angle triangle as well. Alright, and so perimeter, and first of all we can use, before we do the perimeter, we can use our similar triangles technique to work out the unknown value of T. Now I have flipped my similar triangles formula upside down on purpose. Now you might be thinking, well, how do I remember which way around this goes? Well, to tell you the truth, it doesn't matter. It doesn't matter. You can put short at the top, long at the bottom, as long as you're consistent and you have short and long, you know, around the other way, and then make sure all the shorts are at the bottom, all the shorts are at the top or whatever, and the longs are alongside each other as well. So what we've done here, the formula still works, and it's better to do that because we're trying to figure out T, which is our short side, and for algebraic reasons to make it easier, we should start with our unknown letter, and that is our short side over the long side that matches that, matching long side that goes with our short side or similar long side goes, that's 4.9. That's our similar side to our T that we're using to start with. All right, similar, those are similar sides there, those two there, the short and the long. All right, 4.9 and T similar. Now the other one is equal to the other two similar sides, which are 2.8 and 5.5, and once again if we started with short on the top, we've got to put the short on the top again. So we've got 2.8 over 5.5, which is our long side. In order to solve this, the easiest way is to move this 4.9 onto the other side. It becomes times 4.9 on the other side, divided by 4.9 over here. Get rid of the divided by 4.9, left with just the T by itself, becomes times 4.9. And we can put that into the calculator, 2.8 over 5.5 times 4.9. The fraction, you could just do divide if you wanted, 2.8 divided by 5.5 times 4.9, same thing. And we get 2.4949. However, we need to take some extra decimal places there because it's not our final step. Alright, now we do need to work out our U before we can work out our perimeter and our area as well. So if you work out U here, U is going to be start with our longest side, square it, minus the other short side, and then take the square root, and you end up getting 1.2710. And that's not our final result either, so extra decimal places because it's not our final answer. Now this is one of the things we're asked for, our perimeter, so that one will be rounded off to 2dp, and of course you just add everything up that you've figured out so far, the unknown sides plus the one that was already given, the U and the T and the 2.8, and we're trying to find the perimeter of a shorter side, of course, this time, shorter sides this time. So the perimeter of that smaller triangle, right, is 6.57 meters 2dp, and the area of that smaller triangle is those two sides that we just figured out. Alright, so we've got what's the first one there? 1.2710 times anyway, it doesn't matter what order, that's a u and the t, and you're multiplying them across. Alright, so multiplying those two sides at u and the t, which are the shorter sides of the triangle. You always use the shorter sides at an next to the right angle. Multiply them together, divide by 2, and you end up with your area there. It has to be meters squared.